Okay, hi there again, guys. We're going to look at another problem with rates of speed and using ratios to figure out how far two vehicles have traveled. So in this problem, we have a bus and a car. The bus is traveling 80 kilometers per hour, and the car is traveling 120 kilometers per hour. When they started, they were 200 kilometers apart, and we will say that they started at the same time. So the question that we're trying to answer is, by the time these cars meet, or these vehicles meet, how far will each one of them traveled? All right, so we'll just keep it simple like that. We won't add the problem of time in just yet. And we just want to know, when they cross paths, how far will they have traveled? And by the way, before we get into the math here, I realized after I drew this that looks like they're both driving on the left-hand side of the road. So we'll just pretend this is in New Zealand or something. All right. So here we have the bus, which is traveling 80 kilometers per hour. Okay. And the car is traveling 120 kilometers per hour. And we're going to look at this as a ratio. Right. So of the total 200 kilometers that they have driven, or that they will have driven together when they meet, the bus will have driven a fraction of that, and also the car will have driven a fraction of that. But what fraction is that? So let's just simplify this ratio just to make our adding a little bit easier, our lives a little bit easier. Let's just simplify it right away. So we know that 80 and 120, well, they can both be divided by 20. They can both also be divided by 40, in fact. So let's do that. Let's divide this by 40, which gives us 2. Okay, and we're no longer going to write 2 kilometers per hour because it's not 2 kilometers per hour. We're just looking at the ratio now. 2 and 120 divided by 40 equals 3. All right, just like 8 to 12 is a ratio of 2 to 3. Okay, so this is a ratio of 2 to 3. So the fraction of the total distance that we'll say bus drove, bus versus car. Okay, the fraction of the total distance that the bus drove is 2 out of the total distance. And for the sake of creating this fraction, this is a part-to-part ratio. To turn it into a fraction, we need to make that a part out of the whole. So the whole here, 2 plus 3, is 5. So the fraction that the bus drove is 2/5. And you guessed it, the fraction that the car drove, 3/5. All right, so now we have the fraction driven by each. So what is 2/5 of 200? Well, that's what our calculators are for. Although we could probably do this ourselves. We know that a fifth of 100 is 20, so a fifth of 200 is 40, and 2/5 would be 80 kilometers. But let's just plug it into our calculators just to make sure that we're on the right track here. So 2 divided by 5 times 200 equals 80. Perfect. So we did, in fact, do our mental math correctly. All right, so we know that 80 kilometers is 2/5 of 200, which means that the bus drove 80 kilometers. We could just figure out then that the rest of the distance was driven by the car. However, we'll just do this again to make sure that our math was correct in the first one, just to check it out. Okay, so 3/5 was driven by the bus. 3/5 times 200 equals, and it should be 120, or 120. Yeah, is 120 kilometers. Oh, and that, just the way that it worked out, it happened to be the rate, same as the rate of speed, which means that we know exactly how long these were traveling just by happenstance. They must have been traveling for 1 hour because the bus was traveling at 80 kilometers per hour. It doesn't always work out that the distance traveled is exactly the distance traveled in 1 hour. However, it did in this problem. Okay, so let's go ahead and try another one here. I'll just hit pause. If you want to stop the video because you understand it now, you're welcome to. Otherwise, I'll take you through another problem. Okay. So let's just get a fresh page here. All right, so let's say that in this one, I'll just quickly draw us a bus and a car. Okay. All right, and for this one, the car is traveling 50 kilometers per hour, And the bus is speeding, oh my goodness, and it's traveling 70 kilometers per hour. Oh, and it's important that we write per hour, right? Because it's a rate of speed. And these two, let's say that they start off 300 kilometers apart, and they leave at the same time. We want to know how far will each one have traveled when they cross paths, right? So maybe they're meeting for something, and they want to know when will they see each other. All right, so once again, we'll look at this as a ratio. So 70 to 50, 70 to 50, right? And we can simplify that. That's really easy. They're both divisible by 10, so we'll say that's a ratio of 7 to 5, right? Divided by 10, divided by 10. Nice and easy. Ratio of 7 to 5. So the fraction now, just like you guys have been doing in your jump math books, we're going to turn this ratio into a fraction. So 7 out of the total. Remember, this is part to part. So the total is 12. 7 plus 5 is 12. 12, okay? So now we know that the bus traveled 7/12 of the distance, while the car traveled 5/12 of the distance. And notice that if you add these two together, you would get 12/12, right? One full distance. Okay, so now we can look at how far that distance that they had to cover was. It's 300 kilometers. So 7/12 of, notice when you see of in a problem, it usually means multiplied. 7/12 of 300 kilometers equals, and we'll just type that in, 7/12 of 300 equals 175 kilometers. Yeah, and I like to keep my units handy so that I don't forget what I'm doing as I'm working through a problem. Okay, so now let's double check. Once again, we could just use subtraction here, but we'll just double check to make sure that our math was correct by doing the other one. Okay, so 5/12, type this to my calculator, 5 divided by 12 times 300, and sure enough, I get 125, which does add with 175 to make 300, so I've done my problem correctly. So how far did the bus travel? If I was answering this problem, I would write the bus traveled 175 kilometers before crossing paths with the car. Okay? And depending on the problem, I might have to also write a sentence about the car. All right, make sure that you're making it really obvious what your answer is, and double check the question before you move on, just to make sure that you have finished answering it. It's a shame to do all the work, get almost there, and then not quite answer the problem that is being asked of you. All right, once again, if you want to stop the video here, you're welcome to do so. If you would like to see another example, I will do one more before we quit. All right, so let's open up a new page here. All right, so pick a color, green. All right, so this time we have somebody on a bicycle. Oh goodness, have you ever tried to draw a bicycle? Oh, this is gonna be embarrassing. Okay, here's my bicycle. Forgive me, there's somebody on a very strange bicycle, and for the sake of it, somebody on a unicycle over here. Okay, here we go, 2 feet, and he's on a unicycle. Whee! Okay. There's a person over here too. Okay. The person on the unicycle is traveling at a rate of 4 kilometers per hour. Okay, and the person on the bicycle can go pretty fast if you've got skinny tires. Let's say 25 kilometers per hour. All right. And these are two friends that have they've decided to meet each other between their houses, and they live 15 kilometers apart. Okay, so that's the total distance, and they're going to travel the same route towards each other, and they'll just meet when they meet. And we want to know, how far is this poor unicyclist going to have to ride in order to meet his buddy on the bicycle? So let's figure it out. Our ratio of who's going to cover more distance here. We can look right away and we can see that the bicycle is going a lot faster. It's going to cover a lot more of this 15 kilometers than the unicyclist. But how much more? So we can express this as a ratio. The amount covered here by the cyclist will be 25 to 4 covered by the unicyclist. So every hour that they are going towards each other, 25 kilometers will be covered by the cyclist, 4 kilometers will be covered by the unicyclist. They don't have to travel a whole hour necessarily, but this is the ratio. For every 25 covered by this guy, there's 4 covered by this guy. All right, and we can just leave it like that. So let's take a look at how to turn these into a fraction in order to figure out the fraction of the distance covered. So this is a part-to-part ratio, right? Because this guy's going to cover some, and this guy's going to cover some, and together they'll cover 15 kilometers. So 25 out of 29, 25 plus 4, 29. So 25 29ths will be covered by the cyclist, and 4 29ths will be covered by the unicyclist, right? All right, B and U for bike and unicycle. All right, so let's figure this out. 25 29ths times 15, and I don't have to do this. The question that I actually asked was how far the unicyclist will have to go, but I like I've said in previous videos, I really like to figure out both of them just to check my work. So 25 divided by 29 times 15 equals 12.93, and it's actually 931034448, or 3448, but I'll just round it to the second digit. That's fine. All right. And what is that? That's kilometers. Okay, so then we'll use the second fraction here. 4 29ths was covered by the unicyclist. 4 29ths of that, 15 kilometers. So 4 divided by 29 times 15 equals 2.0, and it's 0.689, so I'll say 2.07 kilometers, okay, because I'm rounding to the second place. And so if I add 12.93 and 2.07, I do get 15 kilometers, so my math is correct. And the question I asked was, how far does this poor guy on the unicyclist have to ride? And our answer is the unicycle has to go, or you could say the guy on the unicycle has to ride, but it has to go 2.07 kilometers. And you could even finish that with before he meets his friend, or before it reaches the bicycle. Okay, so we'll stop the video there. If you still are wondering how to go through this, you feel free to watch the video again or to come and find me. And good luck. Enjoy your ratio speed problems.